how to graph linear inequalities. It says to graph the solution set to each inequality. Now, the reason it says the solution set is because when we're graphing inequalities, most of the time we're going to have an infinite number of solutions. Let's see here. I guess the only way we'd not have an infinite number is if it were a system of inequalities, which we'll look at in a little bit, and that would be a very rare occasion that a system of inequalities would actually not have an infinite number of solutions. So we're going to take a look at x less than or equal to 3. Now, we know that if we have a linear inequality that just has one kind of variable, in other words, just in two variables, just the x or just the y, we know that it's either going to be a horizontal or vertical line. Well, if it's just the x, then that means it can only go through the x-axis, and so therefore that would look like a line like this, because it has to go through 3. Now, it's because it's less than or equal to, it's a solid line. So a solid line vertically through the 3, right, through the 3 on the x-axis. Now, I want all x's less than or equal to 3. So let's take a look at which side I would shade. Well, less than seems like it would be on this side, right? That line is just, this red line is just dividing the coordinate plane into two half planes, okay? And so what we're going to do is we're going to shade the left-hand side. Now, let's just say that that's not intuitive for you. If you're like, oh, I can't tell which is less than, we're going to do something called a test point. We're going to shade using a test point so that we can know that we know that we know. Now, we pick a point that's clearly not on our divider, right? Our half plane divider, which is this line right here. So we're going to pick a point that's clearly not on the boundary. And so I'm going to pick the point 0, 0 because that's clearly not on the boundary. Now, I'm going to take the original problem and I'm going to substitute in the values that I see here. Now, there's nothing to substitute in for y because all we have is an x. So I'm going to put in a 0 there. And my question I ask myself is this true or false? 0 is less than or equal to 3. Well, that's a true statement. And that just means that the 0, 0 point is actually part of the true solution side, meaning that any other point that I would pick, any of these points, an infinite number, including the numbers on the line itself, right? Because it's a solid line, so we can include the numbers on the line itself in our solution set. So the only way I can actually give the solution set is to color it, because as you can see, there's an infinite number of coordinate points that would actually make this true. So there's no way I can list them all. I'm not going to try to list them all. I'm just going to color all of them. All right. So the shaded portion is the solution. Let's take a look at three others. Here we go. So now this one I'm going to illustrate or remind you of something called graphing with x and y intercepts. Now, when I have something in standard form, I have a line in standard form, something like that, then I'm probably going to just graph using intercepts. And that just means put in a 0 for y. Well, if I put in a 0 for y, oh yeah, and then I act like, by the way, I act like it's just equals. If I put in a 0 for y, I get that x is 3. So I'm going to put a point at 3. And now if I act like it's an equals, an equation, I put a 0 in for x, then I get this. And I get that y is 2. So there are my two intercepts. Now those are the actual places where my line crosses the axes. So I'm going to continue the line. Now why is it solid? Because it's or equal to, right? This right here is or equal to. And so then I make it solid. If it were just less than, I would make it dashed. Okay, so now let's take a test point and let's see which side to shade. So I'm going to go ahead again, and because 0, 0 is clearly off of the boundary line, then I'm going to put in 0, 0 into my original inequality. Alright, less than or equal to, excuse me. So now 0, 2 times 0 plus 3 times 0. Obviously the left side is 0. And the question is 0 less than or equal to 6? And that's a true statement. Oops, that's a true statement. It's true. So that means that this point right here is on the correct true side of the inequality. So let's go ahead and shade that side. And there's my solution set. All of those coordinate points are actually, they go on forever, are actually part of my solution for that one. And here we go. Now we have one that again has a variable by just one kind of variable, and so it's anything less than the line 4. That's y is less than 4, so it's only going to pass through the y-axis. So I'm going to 1, 2, 3, 4. There's the 4, right? And now it's going to be dashed because that's less than. That means the boundary itself is not part of the solution. It's less than. Now these are a little easier to graph intuitively. So if I say anything less than the line, because this less than is facing the variable, so I say the variable anything less than, I say the word anything for when I see the variable. So anything less than the line, well, it looks like it'll be down below it, and it is. If I put in the 0.00, whoops, if I put in the 0.00, you can, oop, good night nurse, sorry, whoa, sorry about that. Let's try that again. I'm just going to go ahead and shade. It's not working what I was doing, so I'll quit. Alright, so there it is. There are all of our solution coordinate points that satisfy the inequality. And can't remember what I was saying earlier, but we'll just move on. Okay, so this line is not in standard form, it's in slope-intercept form, and so I'm going to go ahead and just graph using the y-intercept first, and then I'm going to use the rise and the run. So I go rise 2 and run 3, put another dot, rise 2, run 3, put another dot. Now what kind of line is it going to be? It's going to be solid. Rise 2, run 3. So I have a solid line, down 2 over 3, and I can continue this slope of 2, 3 the other direction as long as I reverse both of them. And there's my line. It's solid, and I'm going to see which side I'm going to shade. Pardon me. This is the line anything greater than the line anything, right? We say the word anything when we see the y. Anything greater than the line. So it looks like it's going to be up here, right? But let's just say that that's not real clear for you. So you're going to get a test point. Is 0, 0 clearly off the boundary line? Yes, it is clearly away from the boundary line, so we'll put that in. And we get 0 is greater than or equal to 2/3 times 0 minus 1. Well, then that's 0 is greater than or equal to -1, and that is a true statement. So it does indeed look like we're going to shade this side where that true point was found. Now that looks kind of sloppy, so I'm going to come in here with some highlighter, and there you go. Alright, thanks for watching. Hope that was helpful for you.